All right, y'all. Today we're going to be talking about systems of linear and quadratic equations. We're going to kind of be advancing and putting together everything that we've been doing in Unit 1C with solving linears and solving quadratics, a little bit of Unit 1B, and combining it into kind of this really advanced skill of systems that have both linears and quadratics. Because we can have systems that involve more than just linear equations. We could have a system of any set of equations, although we're going to focus in on some ones that we can actually solve, because some of those really complicated systems, you'd have to have technology to be able to solve for those intersection points. But today's focus is going to be on linear and quadratic. And the big thing with linear and quadratic is, of course, you're going to have one linear equation and you're going to have one quadratic function. So let's consider that system we have. X squared minus y is equal to 8 and 2x minus y is equal to 5. And we're going to kind of combine some different skills together. First one we're going to use is our substitution method. And to be able to do substitution, we need to have one of these equations solved for a variable. And the easiest one to get it solved for is going to be to solve for y. So let's go ahead and take that first equation, x squared minus y equals 8. Let's rewrite it. And we're going to solve that equation for y. So x squared minus y equals 8. Let's subtract x squared from both sides. We get negative y is equal to negative x squared plus 8. We can divide everything by negative 1, which is going to get those negatives to cancel out. So we get positive x squared and then minus 8. So relatively straightforward and fairly simple. Now that I have that equation solved for y, I can take this equation and I can plug it in for y in my second equation. So I'm going to go ahead and do that and say that 2x minus parentheses, and instead of y, I'm going to write that x squared minus 8. So x squared minus 8 is equal to 5. Okay. And right now, not a very useful equation. I want to actually eventually be able to substitute, or I already substituted, but solve for x. So I need to kind of isolate some stuff, get stuff out of parentheses. So let's go and distribute this negative here. That's going to give us 2x minus x squared plus 8 is equal to 5. Okay. And then I'm eventually going to be solving this for x, and to solve it for x, I want my x squared to be positive because I'm going to get a quadratic function. I want to be able to factor it. Positive x squared is a little bit simpler. So let's move everything over to the right side of the equation. So I'm going to minus 8 to both sides, plus x squared to both sides, and minus 2x to both sides. And so once we get everything moved over, our 2x and negative 2x, negative x squared, 8 and negative 8 are going to all cancel out. So we get 0 is equal to. And then over on the right, 5 minus 8 is going to give us negative 3. Then plus x squared and minus 2x. And then just rewriting that so that's a little bit easier to see. We can put that x squared first, then our minus 2x, and minus 3. And we, of course, call that descending power order. It is the correct way to write any polynomial. And now we can see that this is a very straightforward quadratic that we can factor. So we want factors of negative 3 that add up to negative 2. That's going to be negative 3 and positive 1. So this would be x minus 3 and x plus 1. And setting both of those factors equal to 0, we would get the x solutions. X is equal to 3. And x is equal to negative 1. So we've done the first half of this. We have found the x values of our solutions of our system. But if I have x, I need to use that x to find y. So I can take those x values and I can plug them into either of my equations on the system. Now, the one caveat to this is whatever equation you plug into, you have to plug both points into the same equation. You can't do one into one equation and one into the other equation, or else you'll get different random numbers and you might kind of get mixed up. So don't mix and match, plug them both into the same equation so you don't get confused. So let's go ahead and take both of these points here, and I'm going to plug them into that first equation for y. And we can actually use our solved equation, y is equal to x squared minus 8, because it's the same one, but then we don't have to do any extra solving when we're calculating that y value. Okay, so plugging in our first number, y is equal to x squared, so that's going to be 3 squared minus 8. 3 squared minus 8 is 9 minus 8, and 9 minus 8 would be equal to 1. Plugging in our second number, y is equal to parentheses negative 1 squared minus 8. Negative 1 squared is 1 minus 8, and 1 minus 8 is equal to negative 7. So I have my x values, I have my y values. I can put those together to get my two solution points, which should be 3, 1, and negative 1, negative 7. So those are my answers, y'all. That is the algebraic method. I know we kind of broke it down, but it is 1, 2, 3, kind of 3 different steps. Do that substitution, solve that first equation for either x or y, whichever variable you eliminated, and then plug back in to find that other variable. So that's our algebraic method. We're also going to look at this graphically. And so to look at it graphically, we want to go ahead and graph it. We have that first equation to be able to graph y equals x squared minus 8. Let's go ahead and get that linear equation able to be graphed. So 2x minus y is equal to 5. Minus 2x minus 2x, we would get negative y is equal to 5 minus 2x. Dividing everything by negative 1, we would get y is equal to positive 2x minus 5. Okay, and I'm going to let y'all practice this part, the graphing. I know you can graph equations. Quadratic functions we can definitely do. We just did that. Hopefully you can do a linear too. You did that back in Algebra 1. Remember, use that y-intercept and that slope. But go ahead and pause the video, graph this one on your own, and then we'll talk about that graph. All right, y'all, so looking at our graph, we have y equals x squared minus 8 there in the red. That's our parabola. And y equals 2x minus 5 there in the purple. That's our linear function. And we should see those same two intersection points, 3, 1, and negative 1, negative 7. So the big thing that I want you to pull out of this is that whether we do this algebraically or we do this graphically, we can come to the same conclusion, get the same answers. Big thing is if you do them graphically, you have to be able to graph both equations. You have to be able to graph them confidently and comfortably. The other thing with graphing is it really only works if you're expecting your points to be nice and pretty. If you get some kind of wonky points, graphically might be a little bit more difficult. If we get fractions or something like that, it might be a little harder to see what those exact points are. Algebraically is a little more foolproof. It should always work, but of course, it's a few more steps. It's a lot more thinking, a lot more algebra that you have to do. So there's pros and cons to each one. As always, y'all, I don't care which method you use. I just care that you can show your work and find the solutions for the equations. Okay, so let's look at some of those explore and explain questions down at the bottom. So like we said, we determined that algebraically and graphically, we get the same answers. And we can find the answer either way. Okay, but let's think about those graphs of linear and quadratic equations just kind of in general. What are some different ways that these two types of graphs could intersect, a quadratic and a linear? So if you want to, you can pause and kind of think on this on your own first and then see what I came up with, see if it matches. If not, you can go ahead and follow along. So if we have a quadratic function, first way that we could have these two intersect is just like we had in the problem above. Line goes through the middle, crosses our quadratic function in two different spots. Pretty straightforward. Okay. Another way that we could have these two graphs intersect is, of course, if we had a quadratic function, but then our linear function only just grazed it and touched it in just exactly one spot. Pretty hard, but it can happen. Okay. And then, of course, last way that we could have them intersect is actually have them not intersect at all, which is if we had a quadratic function like that, a linear function like that, and they're just never intersecting. Okay, so any of these three ways are ways that quadratics and linears could interact with each other. Maybe you got something that's similar, but it should still fall into one of these three categories. Now, what do we notice about the number of solutions? Well, our first one, which matches the example that we just did, we have 2 solutions. That's our traditional, most common one we're going to see. The second set, where it only grades that one time, we're only going to have a single solution. And then our last set here, where they don't intersect at all, we're actually going to have 0 solutions. So for linear and quadratic systems, they could have 2 solutions, they could have 1 solution, or they could have 0 solutions. Okay, it's just going to depend on how they intersect. And kind of a closer, can a system of linear and quadratic equations ever have infinitely many solutions? Well, if you remember back to what we talked about with linear functions and systems, infinitely many is when the two linear functions are the exact same, so they cross everywhere. They're literally always touching. So infinitely many means same two equations. Is there any way for a linear equation, a quadratic equation, to be the same equation? There is not. So since linear and quadratic functions can never be the same equation, they can never have infinitely many solutions. So a little bit of a brain teaser, but some important things to think about. Okay, so now that we've kind of set the stage, let's do a little bit of practice. Let's try some of these out in the wild. And remember, you can do these algebraically or graphically. So let's look at this first one. A, we have y is equal to 2x squared plus 4x plus 3, and y is equal to negative 4x minus 5. Now, these are already both solved for y. So when I do substitution, I can just set these two equations actually equal to each other and go ahead and set up my substitution. So negative 4x minus 5 is equal to 2x squared plus 4x plus 3. And if I'm wanting to solve these, I'm wanting to find those solutions where they're on, I got to get everything to the same side. So let's go ahead and move everything over with my positive 2x squared. So plus 4x plus 4x plus 5 plus 5. We get 0 is equal to 2x squared plus 8x plus 8. And we see 2x squared, 8x, and 8. I can take a GCF out of that because remember, I am trying to factor this. So 2x squared plus 4x plus 4. This is a perfect square trinomial. So square root of x squared is x. Square root of 4 is 2. 1 times 2 is 2. 2 plus 2 is 4. So we get that 4x there in the middle. So this would factor into our first square root x, our second square root 2, and then of course, because I have an addition in the middle, x plus 2, and then that's squared. Okay, so one thing you might note, I only have a single factor here instead of two factors. So since I only have a single factor, I only have one x value to set equal to 0, so x plus 2 equals 0. And if x plus 2 equals 0, subtract by 2, subtract by 2, we get x is equal to negative 2. Okay. And now that I have x is equal to negative 2, I can plug this into either of my two equations to find my y value. So really doesn't matter which one you use. So you can use the one that's a little simpler. So in this case, let's use that linear function. So y is equal to negative 4, plugging in our negative 2. And then minus 5. Negative 4 times negative 2 would be positive 8 minus 5. And positive 8 minus 5 would be equal to 3. So to finish this out, our solution would be negative 2, comma 3. So right off the bat, we might notice on A, this one was a 1 solution. So a little bit different than the first example we did. This time we only got a single solution, which means that if we were to graph this, we would get that single solution. So I want you to go ahead and verify this graphically. So you can graph each of these individually by hand, although that might take a little bit more time. So if you're a little stretched on time, you can use your calculator to graph each of these. But go ahead and graph it, and then we'll talk about the graph, see if we get that same exact answer. All right, so let's check in. Let's look at our graph. So we have negative 4x minus 5 in the purple, our 2x squared plus 4x plus 3 in the red, which of course, like I said, you can do these by hand, but if you're not feeling super comfortable, algebraic might be the way to go, and then you can just use your calculator to check these. This, of course, would be a non-calculator question, but you can use that calculator as we're learning as a tool to kind of compare, make sure you're doing everything algebraically correctly. So we can see very clearly we have that single intersection point right here of -2, 3. It can be kind of hard to tell. It almost looks like it touches a lot. Obviously, my drawing leaves a lot to be desired, but if you zoomed in on a graph, you could clearly see that they don't actually intersect anywhere else except right at that point, -2, 3. And we actually call that linear line in this case a tangent line because it just goes perfectly tangent to the quadratic function, only touching it at a single spot. Okay, so that covers A. I want you to go ahead and try and do B and C on your own. Okay, I will check in and go over both of them here in a minute, but I want you to try and do each of these on your own. I'll go ahead and give you a hint. A is the only one of these that has one solution. So B and C should both either have two solutions or maybe even one of them has no solutions. So that helps you a little bit as you're solving them. So go ahead and pause the video, try and do B and C, and then I'll talk about both of them here in a moment. All right, y'all, let's talk about B first. So we have y equals x squared minus 3x minus 8 and y equals x minus 8. Setting those two equal to each other and getting everything on one side, we get 0 is equal to x squared minus 4x. Now, we could factor this using box method, although it's a little wonky. I think just taking a GCF, which we have x and x, so pulling out an x. So we have 0 is equal to x times x minus 4. And then we can set each of those equal to 0 to get the 2x solutions of x equals 0 and x equals 4. Then you can plug those into either of your two equations. I plug them both into y equals x minus 8 to solve for our y values. And that gives us y equals -8 and y equals -4 to get the two solutions, 0, -8 and 4, -4. So this is a two-solution system, and we can see that very clearly from the graph that we have drawn below. So this one, very straightforward, very similar to our example one that's up on the front page. All right, our very last one, C. C was a little wonky, and I probably was a little bit mean because you probably sat there and thought about C for a really long time before you hit play again. But C is unfactorable. When we set them equal to each other, get everything on one side, we get 0 is equal to 2x squared minus x plus 6. A times C does give us 12, and we want factors of 12 that add up to -1. And because that 6 is positive, those factors have to both be negative. So -1 and -12, -2 and -6, -3 and -4. There is no way we can make those add up to -1. So this is not factoral, which means this has no solution. And we can see that from our graph. Our linear function is going to keep increasing. Our quadratic is just going to shoot up in size, and they're never going to touch each other. Now, you might think, I don't know, those look like they might touch each other eventually. Feel free if you want to graph it. Your Desmos calculator can be really great about this because you can zoom by just pinching. If you graph on the Desmos calculator, you can see that while they get kind of close at first, they really do not ever come close to touching, and they will never touch. And that wraps it up, y'all. That is systems of linear and quadratic equations. Relatively straightforward once you get down to it, as you probably kind of felt on this back page. The biggest thing is just knowing, is it a single point? Is it 2 points? Or is it no points because it's no solution? And of course, if you're still kind of struggling with your factoring skills, that's going to be really important for these. So go back and review some of those factoring skills if you're still kind of iffy on those.